Hey you, yes you clicked on this video because you have a big fear of shaders.
Why are you running? Why are you running?
And I totally understand you. However, although shaders seem scary at first, trust me, they are really fun to play around with once you understand them. So today, we're going to break down the basics by creating 10 simple Godot 4 shaders. So let's get started. We'll start by setting up our scene. I've added a simple sprite 3D with an image of a pretty scenery, and now I'll add a color rect and I'll set its anchor to full rect. And finally, let's create a new shader material and attach a script to it. We'll do all our shader magic inside the script. In the shader editor, we'll start by adding a new uniform vec2 screen texture, but keep in mind that if you're using older versions of Godot, you can totally skip this step because it's already built in. Then we'll sample the color using our screen texture and screen UV. And now we need to create a new float which will be the average of our RGB values. And finally, we can set the color to a vec4 of our new value and set the alpha to 1. And that's all for our grayscale shader. It's that easy. Moving on to our color inversion shader, we still need these two lines of code. But now we need to set our color to a vec4 equal to 1 minus our color.rgb, which returns a vec3 of our inverted colors. And we keep the alpha value equal to 1. And that's actually everything for our color inversion shader. Woo! And now onto our channel filter shader, which is the easiest by far. We just have to choose the color we want and set all of the others to 0. So this is how a red filter would look like, and this is the green one, and finally the blue one. Pretty cool, right? In order to make a blur effect, we just need to sample the color like before with the screen texture and screen UV, but instead of stopping here, we just have to pass in a float bias. I will put 3, and just as simple as that, we have made a screen blur shader. It could be really useful for stuff like in-game menus. To create a grainy shader, we'll start by setting 2 uniform floats, one for the grain amount and the other for the grain size. In our void fragment, we are still sampling the color using our screen texture and UV. Then we'll just generate some random noise based on the UV coordinates and the grain size. And finally, we'll add to our color.rgb the noise multiplied by the grain amount. And that's it for this really simple shader. In order to do a warp shader, we have to distort the texture coords. That way it will give a twisting illusion. We can simply achieve this by just manipulating the UV coords in our shader. So let's get started by setting 2 uniform floats, one for our distortion amount and one for the distortion speed. Then in our void fragment, we start with the UV coordinates, which represent the position of the pixel within the texture. Then to distort our UV, we have to add values to it. So we'll use the sine and cosine functions to create a simple wave-like pattern, and include the time variable to make sure it is animated. And finally, we have to sample the texture with our new UV coords. And that's a warp on this shader, get it? Okay, no, but seriously, I'm absolutely amazed with the results, even if I can't really think of a specific use case, but I'm curious to see what creative implementations you come up with. For this shader, we'll start by setting a scanline intensity value to control the appearance of each scanline, and a float scanline frequency which determines the number of scanlines, and lastly a float speed to control the speed of the lines. And now, in the void fragment, we start by calculating the sine wave to create the scanline pattern by inputting our UVY multiplied by the scanline frequency and adding time multiplied by the speed of the lines. Then, to apply the effect, we simply have to multiply the color of each pixel by a factor based on the scanline pattern. This either darkens or lightens the pixel, creating the scanline effect. And that's all for this shader. Perfect. I have already made this shader before, but I believe if I'm gonna make a video about easy shaders, it has to be here. But this time, I'll take a different approach. We'll start by setting our pixel size. The bigger, the less pixelated the result will be. Then, in our void fragment, we use the floor function to round down the UV coords to the nearest integer. and then we divide it by the pixel size. That way we can scale the UV coordinates back to their original range. After pixelating the UV coordinates, we'll sample the color using our new UV and assign it to our color output. So this is all for this shader. However, if you want an even better looking one, make sure to check out this video. In order to make a chromatic aberration effect, I'll start by defining a uniform float aberration amount. We start in the void fragment by separating the RGB color channels. And for each color channel, we have to slightly offset the UV coordinates, which will cause the colors to shift relatively. And finally, we sample the texture with the offsetted UV for each color channel, and combine them into a single color that will assign to the color output. And that's it for this shader, but this is just one example. We can actually create an infinity of chromatic aberration effects in Godot. And finally, for the last shader of today's video, I decided to make something, different. That's why we're gonna make circles that start at the center of the screen and keep infinitely expanding. In order to get started, we need two uniform floats, one to control our speed and the other for the thickness of the circles. In the void fragment, we need to subtract 0.5 from our UV coordinates. That way, we shift the origin to the center of the screen. This step is very important for our centered circles. Then, in order to calculate the distance between each pixel and the center point in our shifted UV coordinates, we use the built-in length function. And finally, to create the pulsating effect, we use the sine function to create a smooth oscillating wave. And we input the distance multiplied by 50 to increase its frequency, and by adding the time multiplied by the speed, the circles are now animated. And finally, to color our pixels, we check if the wave is bigger than the threshold, and if it is, then we set the color to the absolute value of our UV coordinates in order to make a radial pattern, and if it isn't, we simply set the color to black. And that's all for this shader, and you can also multiply the distance by -1 in order to reverse the movement of the circles. So now you know how to make 10 more Godot shaders. I hope you found this video helpful, and if you did, then make sure to leave a like and subscribe. Anyways, that's all for today's video. Thank you for watching, and I see you next time. Goodbye!